Welcome everybody to the 123rd Melbourne AWS User Group Meetup. It's a big number. As always, we'll start, well, and now you can hear me?
Yeah, no,
yep, cool. In the spirit of reconciliation, the Melbourne AWS User Group acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Also, a reminder, we have a code of conduct. You can read the full thing on our website. Short version is here. The very short version is be nice to each other. If you encounter any problems that you believe are in violation of this code of conduct, please reach out to myself, Rob, or any of the other organizers like Don.
Fourth one isn't here.
Yeah, the fourth one isn't here. Also, just about the user group. These days, we're a bit more active on social media, except for Twitter, because nobody likes Twitter anymore. We also just refreshed our website. We have some ideas for that to make it more useful and fun for the community. Keep an eye on that. We just did. But if you see any issues, please reach out to us about it. As for tonight, we'll start with the introductions, which is the part I'm doing now. Hello. After that, I'll have Jason and Dawn tell you all about what's new in AWS. And then we'll move on to the main events of the evening, which is our speakers, Rinaldi, who was there, and Anthony over there, who will be talking about automating compliance and governance within a continuously threatened technology landscape and low-cost auto-scaling GitLab runners, respectively. Then we end the day with a marketplace. Basically, it's a who's hiring section. If you're hiring, hold up your hands. We'll give you a mic, and you can entice people to join you. Basically, you'll get to say who you are, who you work for, who you're looking for, and people can then reach out to you. The reason we do it this way is in case somebody who's looking for work might be sitting next to their boss, might be a bit awkward if you stand up then. So we'll do it the other way around. And then finally, we'll get kicked out of this nice building around 8-ish. And we'll go on. During the talks, feel free to come up with questions. Generally, if you're online, you can ask them in Slack or in the YouTube chat. If you're here in the audience, please raise your hand or hold your questions until the end, depending on the preference of the speaker. Generally speaking, it's nicer to have them at the end. So save them for them. And of course, I want to thank our sponsors, a gold sponsor, CMD. I paid Chris to do that. And our silver sponsors, Versant and Civo. And of course, we can't forget our venue, the provider of this fine venue, NAB. So thank you to them as well. Our community is active in more than just these meetups. We have a Slack workspace team, whatever it's called these days. You can join it easily. Go to right there, our website/Slack, or click on the link on the website. It's an auto sign-up form, and we've got a lot of people on there. It's over 900 people these days. Not everybody is active all the time, but there is activity going on and some fun discussions to be had, as well as some more useful generic channels that you can go to. If you want to get involved, please reach out. We are currently not looking for sponsors. They're covered for the rest of the year. But if you want to give a talk, and I always urge everybody, please give a talk. Talking is good for you. It's also good for my stress levels, as I don't have to figure out at the last moment who's going to give a talk. If you want to help in any other way, well, there's always volunteers that we can use. Other things that are coming up, the Sydney Summit. I conveniently put some QR codes on these slides. They are covered by my lovely face at the moment, apparently. Cool, they can be shown now. Basically, Sydney Summit is on just a single day this year. Register if you haven't done so already, or if you didn't get any of the 10 emails from AWS about it. Closer to home, in early March, we've got serverless days here. Looks like a lot of great speakers coming there. Tickets are pretty cheap. There's only full price tickets left because it's almost day. Actually, speaking of good speakers, I think Ronaldo is speaking there even, aren't you? Yep. See? Great speakers. So go there. And the other conference I want to plug is DevOps Days Melbourne, which is the week after, which is 2 days. Tickets are $150. Probably should have put that on. This is also a great event, I know, because I'm organizing it. So aside from that, the only meetup so far I found for next month that's been put up on Meetup yet is the serverless meetup, which happens to be the night before serverless days and has speakers from serverless day giving other talks, including serverless developer advocate Eric Johnson from the US. So definitely worth checking out. I think I may have put the time wrong there, but I think they later said they are starting half an hour early. And with that, I'll hand it over to Jason and Dawn to tell you all about what's new. Thank you.
Hey, welcome everyone.
This is quite fun because for the very first time, we get to kick off the What's New in AWS segment with finally in Melbourne. Now that we have almost managed to send finally in Sydney off into obsolescence, we suddenly have a nice new slide to replace it.
Finally in Melbourne.
Yes, so we have Direct Connect in Melbourne. If you have your workloads in Melbourne for some reason and you have decided that you want to set up a direct link between your data center and the nice shiny new AWS Melbourne region, in lieu of having done so in Sydney, you can do this. You can now get super fast internet to the new AWS Melbourne region.
Yeah, and Resource Access Manager. You know, RAM is good if you're doing lots of networking, sharing your stuff. You know, all new good stuff that's coming. The Trusted Advisor, fault tolerance check for Elasticache. Well, that's now GA everywhere. So
yes.
Now in Melbourne.
And Elasticache for Redis now supports auto-scaling in 6 new regions, including Melbourne. This is theoretically not a bad thing, depending on how much you use Elasticache. Speaking of finally in,
Sydney, all the things, well, one, Amazon Connect cases is now available. Now, see, this is where we need Matt, but he's at home with X weeks old. So
very, very small baby.
Yeah, so we'll, yeah, I'm sure for those Connect people, this is probably something good. I'm not much on the Connect side.
Yeah, it means that you can it gets you one step closer to being able to set up a full Amazon Connect deployment in Sydney.
Okay. Serverless. Yeah, step function, adding integration for 35 services, including EMR serverless. So
One of the less server serverless implementations from AWS, EMR serverless. I had my first opportunity to really properly play with step functions over the last couple of months and was pleasantly surprised by how good it is. Adding 35 new services only makes it better. The more things that you can get into step functions, the more likely it is that you can actually realistically orchestrate a full serverless workflow. So this is great.
Yep, yeah. So I was actually talking with Scott, one of the guys in the audience here, about that. So he was pretty keen on that one. Yeah, all those the integrations are really good. Yep. So SAM connections is resource parameter, and the CLI introducing the SAM list command. So more love for people doing SAM.
Yes. That last one I particularly like because that's a feature set that you've essentially had in pretty much every other form of infrastructure as code up to this point. So really the fact that SAM CLI now has that is basically just bringing it to feature parity with every other option that you've got.
And containers. So Snowfelling supporting Amazon EKS Anywhere.
Well, I think our opinions on Kubernetes I think the Melbourne AWS user group's official stance on Kubernetes has been pretty well established by this point, so perhaps the less said about that one, the better.
Well, now you can run it on a box and throw it away.
Yeah, more interesting, being able to use your own training image in a private Docker registry with Amazon SageMaker. SageMaker being one of those services that has started out as a really simple suite and has just grown and grown and grown and grown until it's ended up as this whole feature set. Being able to use your own training images is good for people who want to do really specific things with SageMaker.
Yeah, and app runner and service level concurrency for if you're in memory utilization metrics. I mean, more metrics, more visibility, always a good thing.
Yeah. On to networking. WAF Capture adds support for 10 additional languages. I'm pretty sure that most actual humans who use the internet by this point think that captures are the scourge of the earth, but if you must implement them, you can now do so in more people's native language.
Yep. The GA for the resource map for the VPC in the management console, that's actually super cool. If you've had a chance to play with it, just jump into your VPC, click the new tab for resource map, and you can see where things connect and how they all sort of flow together. Nice little visual utility, and I personally love visual stuff. So.
The NAT gateway increased support for concurrent connections to a unique destination is a really interesting one, and that's one that I suspect was a customer feature request somewhere, because that is almost certainly some sort of scenario where people having to run a very large number of NAT gateways to manage concurrent connections to a unique destination. If you're doing basically through traffic from point A to point B out of a NAT gateway, that's going to make your life substantially easier, most likely, because you're no longer going to have to manage the number of NAT gateways that you run in order to support that traffic.
Yeah, basically an 8-time increase.
Yeah.
Yeah, so.
Which should essentially, for most intents and purposes, make this not a problem for anyone.
Yeah, and the firewall, network firewall now supports tag-based resource groups, so yeah, that'll make it a whole lot easier to dynamically add things in without having to update your policies. So you can just
that'll be nice. Security's got a few interesting ones. AWS config now supports 20 new resource types. Finally, AWS is starting to get serious about some of these security improvements and making sure that the whole the AWS security suite of products actually deal with all of the resources that AWS releases, all of the different types of resources and services that AWS releases more or less shortly after they release them, which is much, much better, to be clear, than it has been in previous years.
Yeah, CloudTrail Lake, spotting ingestion of activity events from non-AWS sources. So there's a whole slew of third-party integrations that were added in. So have a look at the list and you can see all of those.
Yeah, from memory, the one which leapt out at me when I looked at that list is Okta. So if you're doing, if you're basically managing your auth using Okta, you can now ingest all of that data into CloudTrail Lake. There are a bunch of others. That was obviously the one that leaps out to me because of the types of things that I do. But if you want to get all of that data into one place, that potentially makes your life substantially easier in terms of then sending it out to other vendors so that you can actually process it, or processing it within AWS itself. This is something that you definitely want to investigate if you're aiming to get all of that data into one place.
Yep, cool news. DevOps. A lot of people sort of had a bit of a laugh about this first one because I'm very much on the ops side of the things and have done a few talks on systems manager. But yeah, it's probably not as default as it sort of sounds. It means you don't need to actually have a specific role anymore, which, like, that's nice, but you still need to make sure you've got an agent. You do actually need to make sure your EC2 is running IMDS version 2. So yeah, there's still some things that you need to have, and obviously it still needs to get out some way to talk to the SSM service. So
you have to have appropriate networking configured.
VPC endpoint, yeah. So
yep.
There's still some things, but yeah, basically means you don't need to have a role specifically for that.
And my old nemesis control towers there, right at the bottom. Updates to access logging and exceptions to more global services for region deny. Brilliant. It's almost very, very slowly getting to the point where it's a service that I can actually recommend that people use. Still not there yet. Sorry.
All right. And other cool stuff.
Well, this one's where it gets fun because, of course, we have new Graviton instances, M7G, R7G instances.
Yeah, so only in your default regions at the moment, but yeah, running the Gravitron 3, supposedly up to 25% faster than Gravitron 2. So yeah, some nice speed increases. So watch this space for the now in Melbourne eventually comes.
As well as the rest of the suite using the Graviton 3 processors is presumably going to be rolled out as time goes on. You've got the M's and M-class, R-class, which are two of the more commonly used ones in terms of Graviton processors. I'm waiting for the point when the C7Gs hit. That's probably where it's going to start getting quite interesting.
Yep, and yeah, I think a lot of the others are all, pretty self-explanatory. So, the programmatically managed, enabled and disabled opt-in AWS regions on the account. So that will be a time saver for a lot of people.
Yes.
Just remember, you do need to upgrade your AWS CLI for those new CLI features to be shown up. Caught me for a little bit. I was like, why the hell is this not working?
It does mean that you can at least batch this now, which is something that you never used to be able to do. It's the balance between the AWS APIs not needing to add support for every region initially as immediately it's set up, and actually being able to readily programmatically manage that. The other one here, which mildly amused me, is AWS announces access of simple monthly calculator estimates in the AWS pricing calculator. One of the more famously opaque aspects of the AWS AWS services in general and the AWS documentation, which, to be honest, I find a little bit opaque to begin with, has always been working out how much it is actually going to cost you to run something before you set it up and run it. So I'm really curious to see whether that brings benefit in that regard, and if it does, what sort of benefit we can expect.
Yeah, so it sort of seemed to pull in estimates that you've previously had created in the simple monthly calculator before simple monthly calculator gets depreciated later. So,
Yeah, welcome to the AWS ecosystem, right?
yep. Yeah, so that's pretty much our wrap for what's new.
Yeah. Back to you, Ian.
Cool. Thank you. Then let's switch to our first speaker. Rinaldi is a software developer at Seek and a developer advocate in the tech community. He's also an AWS community builder in the serverless category. Through his passion of developing software and contributing to open source community, Rinaldi wants to encourage the innovation of new solutions to usher forward and promote code that can be used by everyone. He also writes very, very long intros. As part of this, he has been a tech speaker in more than 20 events for the past 5 years and runs tech meetups and workshops to promote better understanding of technical skills. And in his free time, he also enjoys track running and playing chess. So, give it up for Rinaldi.
Cool. Thanks for the intro, Aryan. Hello, everyone. Glad to be here and hope everyone's been enjoying the great food and great vibe so far. So, start off with, as I introduced, I'm Rinaldi, and pretty much from Seek, and going to be giving the talk automating compliance and governance within a continuously threatened technology landscape. So this is pretty much going to be the agenda. So it's pretty much going to be firstly going to talk about the motivation for a bit first of like why we particularly are looking into actually discussing this in the first place, why we need to talk about compliance, why we need to talk about how we can actually use AWS config as part of this. And after that, we're going to be going into a bit of the talking about some architectures as part of these particular configurations, that what we can build with essentially with AWS config and such. And afterwards, talking about how we can also utilize AWS config as part of this. And I'm going to be talking about a little case study of mine as well. And finally, going to end the session with some key takeaways. So just a bit about myself. So as are introduced, pretty much I'm from Seek, and have my socials as well on display as well, and pretty much been quite active as well within the open source community. Been active within the AWS community for quite a while. Been going to different conferences, events, and also different community groups as well. Participated in community days as well. So been quite around for a while in this space, and I enjoy talking about a lot of topics, including DevOps and recently security, because even more so security these days, because there's been an even bigger need for that, as I will also talk about in the NIST slide as well, which is, I'm sure everyone here is familiar with greater data breaches that is currently happening with our communities, such as with Optus and Medibank, which until now actually is still talked about within companies. I mean, at this point, Optus, within Seek itself, Optus has talked like the boogeyman at this point. It's something that like everyone knows that they already got at this point, and everyone just it fears that particular name nowadays, like being brought up. And it's being used as the case study, which is for like a lot of firms as well, of like preventing insecure access as well. So it's a very, very bad thing, and essentially that's why we need to talk about this and compliance more as well. And of course, there's yeah, more work from home workloads as well, causing more workloads to be run on the cloud too. Ever since the COVID-19 pandemic, a lot of companies will switch to that as well, which is why it's even more important for understanding how different firms can work with different things as well within the cloud. And finally, of course, with audit requirements as well, because especially with compliance requirements that you get from different providers that you may be running your workloads on, you more or less have to understand this as well. So firstly, just get a show of hands actually. Who here is operating AWS accounts with more than one account within an organization? Cool. Quite nearly half of the room. That's great. Who here is looking to shift towards having multiple accounts within different within your organization? Okay, gotcha. So let's get it straight into it. So pretty much, I'd say that most often times this is becoming a topic more or less more important, I'd say, for more established organizations, but more or less it's certainly a topic that will continue to be looked at as people start to essentially proceed as well, and essentially look to essentially grow more or less as well within their accounts. Because oftentimes when you start to grow your workloads, when you start to grow your compliance requirements, you start to essentially branch out your service to different locations, different offices. That's where, and of course, giving yourself more need as well for what you need to work on, and essentially what you want everyone to essentially to delegate access to different people as well. That's where you start to bring in multiple accounts as well. And that is why it's also essentially it's for that particular purpose that a lot of times the multiple accounts are discussed more closely as well. So now I'm going to be talking a bit about self-service particularly. So what do I mean by self-service? Essentially how a lot of companies essentially start to approach self-service, particularly within approaching the organization requirements as part of bringing ahead self-service requirements into the mix essentially. So organizations often need a self-service platform for a lot of employees and customers alike to essentially like get help on their own as well. So pretty much as part of this as well, they often operate in multiple accounts as well as part of this. So usually when you essentially start planning for self-service, it goes through a 5-step workflow essentially. So firstly, it's plan. After that, it's discover, and you move then to design, and finally implement, and afterwards iterate. So within plan, you start to actually analyze your use cases, particularly within the platform, and then you essentially need to continue discovering the different options that you have. How do you want to design your workflows? What SAs can essentially help with this, and essentially work through helping you find the best options, particularly as part of this particular workflow. And you then want to set up a development framework, essentially, on how you essentially want to go about trying to develop it and try to essentially work on it. And afterwards, you start implementing the appropriate AWS services and implement the appropriate processes that are already part of what you are doing. And finally, you then look to iterate on it and continually revisit and adjust accordingly based on what you already have and accordingly plan as well. So what are the biggest challenges as part of setting up these particular workflows? One of the biggest challenges is that you often will encounter the biggest challenge of having both business agility and governance, because over time, and this is, I'm sure that this resonates with most of you as well. When your organization grows bigger and you start to have multiple accounts, it becomes much, much harder essentially to also govern them and also to more or less at the same time have the fast decision making, because oftentimes when you essentially adopt agile, and that's why we have agile, right? When you adopt agile, when you essentially look into doing processes quickly as well, you often need to go to a hierarchy, which then you need to essentially work through this workflow, which then has to go through that workflow. So that is essentially the biggest challenge as well as part of this, which is why we're discussing this topic as well, essentially, of like how we're able to do that, but also do it securely as well, while maintaining the appropriate compliance. And aside from that as well, we often need to consider as well how we establish our particular standards as well, which is also a big challenge as well. And also accordingly design configurations before launching and managing as well. So as part of this, oftentimes there are a specific skill set that needs to be obtained as part of this, and essentially to be able to understand what we need to obtain as part of the standards and how we essentially also design these particular configurations. But it's a very specific skill set, particularly especially when we look into designing for multi-account organizations. And after that, we need to also establish baselines for each particular environment. Established based on particular frameworks, established based on what we already have, a foundation essentially based on what we're doing as well. So this should look pretty much standard to most people. So here I'm sure, but essentially it's environment standards such as having a sandbox environment to test things around, and pretty much like move on to development after that, and pretty much like have a standard staging environment as well, and after that moving to production. So should be pretty straightforward as well, pretty much. So when we talk about self-service architecture, this is more or less something that I'm referring to particularly. So when we look into the different self-service architectures, this is, for example, one that is based on ServiceNow, for example. So just out of curiosity as well, anyone here use ServiceNow as well? Gotcha. Few show of hands, pretty good. So pretty much, yeah, so ServiceNow essentially is more or less the best way to describe it as is kind of like for those who are not aware of it, ServiceNow is more or less a platform where you essentially get to handle a lot of support help, essentially, and handle a lot of the requests from people inside your organization, and could be from outside as well. But particularly, it's usually for a self-help platform. And particularly, so the workflow usually goes, user request goes ServiceNow, and afterwards, this is where we start to essentially modify things a bit, especially when we start to actually have multiple accounts. So we have AWS's connector for service management, which actually connects to ServiceNow. AWS is able to connect to quite a few of these self-help providers as well. So it's ServiceNow is one of them. And afterwards, how we essentially started to design it for multiple accounts is essentially having it connect to having the service management connector connected to our AWS environment, which actually has a service catalog, which essentially helps to more or less get the catalog of a service that we currently have running in our environment to AWS config, which essentially helps us to also understand what the actions have been performed are, and systems manager to also more or less manage and control our systems pretty much within AWS as well. So having AWS config in the mix really helps with tracking as well, what we're doing in the environment, and also more or less standardizing our parameters as well. And same with systems manager to also control what we do as well, which is then also sent towards, based on what we are currently doing as well, the request then sent to our service as well within there, EC2s, S3s, workspaces. So pretty much we have this flow with the intermediary being ServiceNow towards AWS, and that way we're able to track these particular actions and actually have these actions perform accordingly based on what we're currently doing based on the environment. Oh, yep.
So can you go, yeah. So in this workflow, where is the approval path happening?
So
How many workspaces I will be provisioning? How many EC2 instances I will get out to provision through this portal?
So it's most of the time it will come from ServiceNow. So pretty much most of it will be reviewed within ServiceNow. So pretty much most of it is ServiceNow, which is then sent accordingly. The actions sent accordingly to AWS accordingly, but mostly it'll be pretty much like done to ServiceNow. Yeah. Gotcha. Any more questions before I proceed?
Can you just make sure you face the podium, please, so we get the proper audio pickup from the mic?
Oh, gotcha. Will do.
And if you do have questions, please wait for the microphone. Don't just shout out.
Yep. So yeah, again, feel free to stop me anytime as well if you have any questions as well. I want to try to encourage as much interactivity as well. So yep, feel free as well, and I'll take questions after sessions as well. Either way, it works with me as well. So afterwards, yeah, just a bit about AWS config as well, particularly about utilizing it. So in case you are not too familiar with AWS config as well, it pretty much helps to track configuration changes made to the cloud for up to 7 years. And you're able to also evaluate changes as well within compliance policies and within AWS config rules, able to integrate providers, so as you have seen within architecture before as well, such as ServiceNow. And you're also able to provide an aggregated view of compliance, which is what I'm going to talk about in a bit as well. You can get essentially a full view as well within an AWS config as well of the different configurations that you have and what are not compliant, what are compliant, what actions do you need to remediate them. And they also give you essentially more or less recommendations as well based on what you do about it as well. So it works hand in hand essentially as well with a trusted advisor most often, I find as well. So it's very good for this particular use case. And going a bit deeper as well into AWS config, we're going to be mentioning rules quite a bit. So I thought I'd introduce rules as well, particularly within this. But you use rules within AWS config to set and evaluate policies essentially within AWS config. So aside from that as well, AWS config offers a range of pre-built rules, which usually covers common compliance requirements such as, and I'm sure based on the different industries that are here as well, these may already sound quite familiar to you, especially, for example, PCI. And if you're in healthcare, you have a sensitive information within healthcare information. You may know like HIPAA and also CIS baselines as well. And that being said, although pre-built rules are usually useful, you may have specific compliance requirements that are not covered by the pre-built rules, and which is where custom rules then come into play as well, which you can essentially set into automating and accordingly putting into place as well. And speaking of automating, essentially, this is just an example of a sample workflow where you essentially automate your config as well. So one of the things you get through as well is you can essentially set up appropriate notifications as well as part of your rules, essentially, especially when you have config that are not essentially currently being valid or essentially not non-compliant. You can essentially put ahead some config rules to be able to look at this as well, and also accordingly, for example, work with snapshots on S3 as well. So as part of this, I'll just explain the workflow for a bit as well. So you will essentially look at changing resources, particularly, for example, when you actually have a new resource change. For example, you're looking at having new EC2s being like upgraded, for example, or you're essentially looking at having new Lambda functions being added in. And afterwards, that goes into then AWS config being detecting the changes, and where it'll be then normalized, which is then sent to the AWS config rules, which then detects it accordingly. Is this appropriately configured, or is this not? And depending on that, it can take a few different actions. So particularly as part of this, firstly, it does store it into an S3 bucket, particularly as part of the history, and accordingly also makes snapshots as well. And aside from that as well, it could also access APIs. But the most important part of this really is that you can detect things and also accordingly respond to it accurately and quickly with a SNS. And if you've been working SNS for a while now as well, you already know that we can take quite a different number of different actions as well with SNS appropriately. We can also automate it to take specific actions. We can accordingly send it to our email as well. We can have it sent to our text messages, and we can essentially have alert based on this. So it's a really great way of preventing any small unauthorized changes from happening, or maybe that loose API that you've been provisioning, which, as we've seen with data breaches such as Medibank and Optus, are very costly over time. So having appropriate rules and appropriate configurations set up to prevent these kinds of changes from being impactful for your company can actually help out a lot as well. And just a bit of a talk about conformance packs as well for AWS config before we move on as well. So conformance packs for AWS config are more or less the best way to describe it is it's essentially just kind of like a collection of AWS config rules. So you have a configuration of that. You essentially have it within one conformance pack per se, and you essentially have this pack to more or less detect all these particular changes, just particular, essentially these particular rules to detect these changes, and accordingly act based on that as well. So you can also like author a YAML template if you're already familiar, for example, with what you're doing with the YAML files, with like, for example, with when you try to make deployments based on CloudFormation and all that. You can also make a YAML template as well for this too, which contains a list of rules. And appropriately, as you can see, there are different services that are listed on there as well. Didn't label them, but you can probably tell by their logos as well, like EC2s, S3s. Like essentially, as part of this, you essentially will have these all logged as part of the AWS config. And essentially, as part of this, you then have it sent to the S3 bucket as part of snapshots, and as part of storing the different configurations that are stored as well, and based on the history. But at the same time, you're also having it audited as well through the AWS config conformance pack as well, which then evaluates them based on the rule sets that you're providing them, where then you start to essentially have the evaluations then stored. And so you have the evaluation stored, which is then can be acted upon. For example, you can connect to services like CloudWatch, for example, to also detect your compliance as well, and also accordingly have SNS as well to stored in and act based on the notifications that are being sent as well. So it's a great way pretty much to automate more or less these configuration changes, and more or less also act based on when you have multiple accounts. And as part of this, we're building up to talking about how we're going to use this for multiple accounts as well. We more or less can also report with aggregators as well. So aggregators more or less are kind of like a way to more or less summarize and more or less kind of like aggregate the results that you already have within your data into an aggregated view pretty much. So for example, when you have different accounts and regions, you have AWS config data, you put it into an aggregator, which then creates an aggregated view for you to more or less understand and some a kind of like a summarized view of your data. And we then pretty much use all of this knowledge to essentially start to create some workflows. And this is an example of one sample workflow that we might have as part of the different accounts that we have. So oftentimes, how it usually works is that, at this case, for instance, we have a centralized account which more or less keeps a lot of the audit work that we want to do. So we have the Lambda functions, for example, that we are using to run sample audits that we want to do. So particularly for different accounts and our centralized account, we have config from the managed account, which is based on all different regions that we're currently based on, which then sends appropriately the data, the configuration data that we're trying to get audited as well, basically into the Lambda functions as well. So pretty much as part of this, we send it through, and for example, we also have a centralized account which might be in AP Southeast 2. We send it through to be able to then be queued for the audit, which is then placed into the Lambda function audit as well. So essentially, this workflow helps with more or less detecting the audits that we need to do as well. But at the same time, we have another function which we can essentially set up as well to accordingly act upon what we want to do as well. So to send it to the queue and afterwards put it to AWS config as well at the same time to more or less manage what we currently have as well for the audit too. So more or less it's kind of like a central workflow process that we want to try to create as part of this workflow. And a remediation workflow is a bit more complex than that. So as we can see over here, we may have different managed accounts and it's another centralized account as well. So what is different from this is that we're essentially trying to put a workflow essentially on trying to detect, like for a non-compliant resource, for example, and accordingly try to remediate based on what we're currently trying to do as well. So as part of this, within the managed accounts, we can see that we have System Mesh Manager automation, essentially to more or less automate what we need to do, and more or less the workflows that we need to like put in place, and have config rules as part of this. So pretty much within this, we start to essentially have the config rules put through to decide what we need to do as part of this, and accordingly also have automation to put it through to the SQSQ as well, to have different events to also remediate as well as part of it. And afterwards, it can be then sent to the Lambda function, and the Lambda function essentially can send data back and forth essentially from DynamoDB, for example, in case there are any exceptions in this particular case. And it then sends data as well through the another SQSQ, which can then be sent for remediation in particular, but it can also be sent to Systems Manager as well in this case, so that you can essentially also automate what you need to be fix as well as part of this. And if you've sent it to the SQSQ to remediate, on the other hand, you then send it to a Lambda function, which then tries to check for non-compliant resource essentially. So this way, you're able to more or less try to detect these particular cases. So as you can see, when it goes to Systems Manager or the Lambda function, you can essentially make it go through to the managed accounts essentially to where the non-compliant resource is, to try to find it and accordingly tag it and appropriately take actions as well. So this way, it's able to remediate the actions accordingly based on that. And when we set a notification workflow as part of this, we can then look into more or less still having kind of like the same workflow as well. But in this kind of case scenario, we still have centralized accounts and managed accounts. But in this case scenario, we have the AWS config rules in them, and within that also set up for example, in this case scenario, we'll use event bridge. So we will essentially set through a event bridge event rule, which is then sent forward towards the event bridge default event bus. But across all regions, we'll essentially have this particular workflow. So the event bridge default event bus, which is will then send the information to the event bridge event rule notifications, which then sends to the SNS topic notifications. So this way, you'll get directly alerts based on that, and also notifications accordingly, and also actions that can be taken accordingly as well, which is sent to the SQSQ notifications, sent to the Lambda function, which then sends to your email and sent internally to you as well. So this is particularly like a sample notification workflow of how this may work. So you can see from this particular workflow how more or less these particular configurations can be taken from AWS config in this particular case scenario to eventually move its way towards using the different rules and according to different notification rules as well, to then move into the different alerting as well based on the centralized account that you have to then send an email notification to you essentially as well. And pretty much we're actually approaching the end of my talk as well. So just gonna cover some quick features as well from config that actually were announced as part of reInvent as well. But thought I'd highlight these three particular ones particularly because I found them very, very interesting and very good to highlight as well. So the first feature that was very interesting for me was the announcement of the proactive compliance for config rules. It's a very powerful feature, I'd say, because it enables you to pretty much check prior to provisioning your resources. It's able to make you enable you to check what you're configuring and what your configs will be essentially before you actually start to provision the resources and if they'll be compliant or not. So it's a very good new update, I'd say. And aside from that as well, you also have comprehensive controls management as well for AWS Control Tower. You're able to implement different controls across all of your accounts within minutes as well at scale. So I'd say it's also a very good feature as well to look towards as well. And finally, we also have the Amazon CloudWatch cross-account observability, which helps you also troubleshoot your different applications, particularly within multiple accounts, quickly too. So these three are very great features to have particularly. And I've been doing a bit of digging as well. Haven't managed to actually observe it that deeply as well, but managed to starting to take a look at that as well, because I do believe that these are very important tools to, and very important features to look towards having as well, I'd say, within our different accounts and different builds as well across our environments, because it's able to help us with our provisioning, monitoring, and more or less how we're looking to aggregate the information as well across all the different accounts that we have. And just a quick case study as well of more or less how I've been more or less like approaching it as well. So particularly, this is a case study that I had personally as well within company as well. So pretty much one of the things that we've had as a team as well was within having a problem with the different costs as well, from more or less what we're doing within patch management as well. We have lots of different patches like coming across. Some of them are essentially, some of them are more or less for outdated patches. So we used to have like vulnerabilities a lot. Essentially, we have a bit like kind of like it becomes like a bit hard to manage over time, because well when you leave kind of like patches like like when you have like on-prem Python-based server, Java-based servers, Python-based servers, or other applications like that, oftentimes suddenly like next thing you know, these servers or the add-ons that are part of that, the extensions that are part of that get outdated, and next thing you know, you have like a lot of alerts, particularly from whether it be from your in-house solutions or from AWS config, that they actually have to be patched pretty much. So we had pretty much a problem of this, and we're pretty much within the management of this, which created a lot of costs. So as part of this, we then pretty much looked into how we could fully automate, particularly using CloudTrail and config. So we created a particular workflow essentially, and essentially of like how we will more or less kind of like automate these changes, more or less have like a self assistance kind of like workflow as well, which is why I also brought the whole point of service now as well into the picture as well, of like how we can actually automate these particular services to being put in place as well, and these particular changes to being put in place as well. So we looked into fully automating it. So we went through with it. We designed architectures based on it, and more or less what we eventually did was we decided to pretty much like look at automating it. We managed to have appropriate logging, appropriate changes as well based on AWS config, and over time we managed to save much more as well over a long-term scale, because we pretty much implemented more robust system rather than doing more or less like manual reviews, just having it instead listed, aggregated over a view, and more or less automated as well, more or less, to come to us at the same time. And if it's like, for example, minor patches, they'll like do it directly as well. And if it's major changes, then call to our attention as well. Either way, we avoided both costs and also managed to also comply more towards what we need to do as well for compliance, and more or less try to avoid any unnecessary security breaches as well that way too. So as a lot of presentations do, I'd like to end this with a quote. It's very hard to find a quote about compliance that is actually from someone that everyone knows. So I pulled this one anyway, because I feel that it is a pretty good quote, I'd say, to more or less compare this actually to insurance, which is very interesting. But yeah, it's about from someone called Adrian Hodgkinson, basically saying that insurance is a highly regulated industry where security, governance, and compliance are key. Big insurers have large budgets to tick all the boxes, but it can be more difficult for our smaller insurers like us to ensure compliance. Having used AWS previously, new scalability and flexibility of the AWS could help us quickly adapt to changes in the industry. So more or less kind of like another case study, but like a brief case study, but also can be a quote as well. Either way, it helps to more or less summarize the importance as well of having appropriate compliance as well, I'd say. And what are the key takeaways? We need more compliance within today's cloud-based world. It is becoming an even more important thing over time. It is becoming more apparent as well that AWS config is a powerful tool as well to build compliance workflows around, and we just really need to be able to stay updated with the latest features. And as seen as well from the earlier what's going on with AWS section as well, and what it's very important as well to stay in touch with what is currently updated as well, based on stuff like reInvent and based on the monthly updates as well, so that we can appropriately also use the controls as well and the necessary new updates as well to better secure our accounts, make our life easier, and and more or less have happier stakeholders as well, both internally and externally as well with our customers. So that is all. Thank you. And before I end this, I think there's time for questions. Yeah, is there still time? Is there any questions from the session?
No questions? I didn't see any online either.
There's two.
Sorry.
One behind you on the.
Hi. So my question is, in the pipelines that you've showed, is there any way to identify the patterns, especially for public-facing applications where you get basically traffic from a lot of places? It can be sort of difficult to identify the breaches in the infrastructure. I know you've covered infrastructure in terms of config changes and monitoring them, but most of these threats that come in access the data. So is there a way to identify the patterns, and if so, does this pipeline help in that?
Thanks for the question. Sorry, what's your name?
This is Ashwin.
Sorry?
Ashwin.
Harshman?
Ashwin, yeah.
Harshman? Thanks for the question, Harshman. So I'd say that, just for the clarity of everyone watching online as well, the question was, what was the patterns essentially? Sorry? Oh, they all heard? Okay, gotcha. Yep. So answering the question, Harshman. So pretty much I'd say that identifying the patterns comes from two different things, I'd say. Like, firstly, I'd say that there are definitely tools within AWS that you can use, particularly within pretty much like for more or less like proactive like threat detection. You can essentially also use for pretty much like patterns for that as well. Like for example, like Inspector is one of them. Let me actually cover like the manual approach first though. So the manual approach is the most traditional one because oftentimes it's more or less trying to based on your historical patterns and more or less the like attempted breaches, for example, or attempted failures in compliance, for example. That's like one way of like doing it. It's kind of like based on your history, and aside from that as well, is also to base it off of the security baselines as well. Like I mentioned before, like we have stuff based on AWS provides us stuff based on security baselines like CIS or HIPAA and essentially stuff like that. So that is like one way, but with the built-in kind of like ways of like doing it based on the patterns. But if it's pretty much from if you want to detect more patterns, it's usually based on there's usually like Inspector is like one of them, or aside from that as well, from using kind of like ML based kind of like ways of like learning about these different threats as well, and more or less like feeding data into it as well that way as well is another way, I'd say, of another popularly increasing way pretty much of how a lot of organizations are looking towards tackling it as well. So those are the different ways at least that I'm familiar with pretty much of like looking into this. Yep. I think there was one more question just now.
Hey, thanks for your talk. It was really good. I'm actually looking into this at the moment as well. I want to implement a couple of these security tools in our AWS environment. So you talked about AWS config and also mentioned Trusted Advisor. Would Security Hub also play well into this sort of ecosystem? And then on top of those three, are there any other that you'd mention to implement?
100%. Sorry, what's your name?
Oh, Kartik.
Kartik? Great question, Kartik. So 100%. Security Hub really serves as a great, it serves like a good complement, I'd say, to the other tools as well, because I'd say it really helps pretty much within more or less centralizing like the actions that you would take and more or less kind of like the detection of like the different threats as well within the environment. So 100% I'd say it really complements it as well. For other tools, at least in my experience, we in Seek, we've used different tools. pretty much these are usually from third-party vendors though. So we use tools for alerting us, like for example, like Datadog, for example, is one of them. We essentially help to aggregate information to Datadog, help them to also like set us up like notifications as well as part of this, and also Ops Genie as well, if you're familiar with that as well. We use that as well, particularly for alerting us as well based on the different notifications as well. So more or less, we use these particular tools because there are some metrics that we find customizable that are better suited for Datadog, and pretty much we just decided to particularly use that because of those services. But overall, but yeah, that was a long-winded answer to your question. But to shorten the answer, yes, there are definitely different. You can definitely use a Security Hub, and yeah, there are different services definitely that you can use for helping you with as well, like Datadog, for example, and yeah, Ops Genie. And I'm sure there's more as well that the audience here is all familiar with as well. But yeah, those are just two example ones that at least like within my organization that we use that helps us for detecting these kinds of things as well to help us notify us based on threats as well like this.
Awesome, thank you.
Thank you. Any more questions?
No, we'll call it there. Thank you very much.
Thank you. Thanks, Arian.
Thank you. Thanks, Rinaldi. Then it's my pleasure to introduce our next speaker, Anthony Scala. He's a principal engineer focused on platform engineering. He's worked with AWS for 9 years.
10.
With 10. You should update these things. With additional experience across other things, other clouds that we may not name here. So please welcome Anthony.
Didn't So welcome everyone. So tonight just talking about some of my experiences and some of the things that I worked through when I was building something for a CI/CD pipeline in GitLab recently for some internal work that I was doing. So based off that introduction, I'm Anthony, as mentioned, principal engineer for Digio, focused on platform engineering. Have a development background, so did some dev stuff back in the day. 10 years of experience in AWS, I think it's like to the day now. Been doing infrastructure as code and that type of thing for 12 years. I was reminded just before I did this that I was AWS certified and I let my certification slip. So that's not very good of me. So maybe one day I'll actually get back into doing my certifications. Usual spiel, I am a consultant. I work for Digio and the wider Mantle Group. We are a large organization of over 800 people. We kind of got people in digital space, people who do platform work, AWS, those other clouds, AI, ML. So if you're interested in pretty much anything IT related, come and speak to us. We have people that work across the whole of Australia and across the ditch in New Zealand as well. Got some perks and things like that, like Magnetic Island. Many different brands as mentioned here, but I won't go into too much detail. So like I said, we kind of work across the gamut of IT industry. So if you are interested in a change, something a little bit different, have a chat and I'm sure we can find something. So maybe if I step back a bit and think about the problem that I was trying to solve here. So as a consultancy, we go out to companies and we build pipelines and CI/CD things and we build AWS accounts. And that's great and we do them for the clients and we get paid. But we're really terrible at doing this internally. It's just one of those things, you don't get paid to do stuff internally. You know, there's never any time, there's never any people allocated to that type of stuff. So we had some examples of some services, some little applications we needed to build internally, and someone goes and builds it, does some work, goes, I'll deploy this manually through AWS, that's fine. Jumps off that piece, the work goes to a client, leaves the organization, essentially gets stuck to the next person to kind of automate that thing. So we kind of get to the situation when people are pointing fingers, like, oh, I need this little internal app built, so I need it deployed and it updated. You know, people pointing fingers at each other. The classic, oh, I deployed this from my machine, that works. You know, why doesn't it work on your machine? And being a platform engineer and someone who looks at kind of CI/CD pipelines, I always think to myself, you know, how can I automate this in an efficient manner? How do I kind of make it cheap and remove this kind of dumpster fire that people kind of get left with on some of our internal projects? And a lot of this was then around cost. So how do I make this cheap and repeatable? And how do I make it in a way that's actually something that's going to be reused by multiple projects, so I'm not just solving one internal problem? And being that my solutions that I was working with were hosted in AWS, I wanted something that was quick and easy, high quality, low cost, and something that I could leverage things like serverless technologies. And when we talk about serverless here, we don't just talk about Lambda functions. There are a lot of other services that we'll talk through tonight that essentially are serverless, things that you don't have to manage, things that you don't have to worry about upgrading, patching, or dealing with, that we leverage in order to build out a little system for us that's really easy to use, high in quality because it's less likely to break, and then leverage these technologies for things that are also low cost. And again, as I mentioned, yes, we're a consultancy, but we try to do things on the cheap when we do it internally. You don't necessarily want millions of little bits and pieces running inside your AWS accounts, because next thing you know, you end up with a bill for a couple of $1,000s for stuff that you didn't really need. And that was the thought process here. So being an infrastructure engineer and a platform engineer, I was like, how do I leverage my skills in Terraform and scripting to build out a solution? I'm not trying to sell this thing that I'm talking about tonight. We're going to talk more about the AWS implementation. So I built this auto-scaling GitLab runner. There's a whole spiel about this, and I'll talk about the architecture in a little bit. But essentially, we want an environment where we've got changes into GitLab, where people use Git flow, whatever it might be. We want to make those changes available and deployed into an AWS environment that's quick and easy and something they don't have to worry about. They don't have to worry about having to patch certain bits and pieces. So there was the reason for building this thing, and we've got it published out on GitHub onto Terraform as well if people are interested to download it and have a look. So we've open sourced this because it was something that I found useful for myself and running it through quite a few internal projects. So I thought, if I found it useful, there's probably use cases out there for other people as well. And just to go through the thought process again, we're trying to leverage low or no cost services, the things that are serverless inside of AWS, things that don't provide much maintenance. We don't want to expose ourselves to high level of security as well. Some of these little apps we've got running for 3, 4, or 5 years, we don't want to have to go and do things like patching. We don't have to worry about someone hacking that, getting access to this little part of a CI/CD pipeline that then provides problems for us in the security space for the rest of our organization. Things that are well known, things that are easy to deploy, things that aren't too crazy. You see this, the diagram was there, it's not there anymore. Oh, it's back. You don't want something that's too crazy using too many moving parts. We want to kind of keep it just right. And as part of a pipeline, we want these things to be quick. As with anything, we want to make sure that as people are working on stuff internally, they're getting fast feedback. 2 or 3 minutes to deploy a piece of code or whatever it might be into an environment, essentially from nothing to getting this deployed out. The solution I talk about tonight is not necessarily something that's going to work for everyone. But again, hopefully throughout the presentation, you hear about some of the ways that we solve these problems and some of the services and the ways we leverage them, and some of the techniques more than anything. Like I said, I've got this working on a few internal things, doesn't mean it's right for other people, and it's kind of a food for thought type of thing. So when we look at the architecture overall, it's fairly simple. We've got a GitLab server that's hosting our code. It's what's triggering the pipelines, for those that aren't familiar with GitLab. And this was our first kind of incarnation of this. So we use things like EventBridge, we're using Lambda, we're using CloudWatch and rules, and essentially we just get an EC2 at the end, and that's what's actually executing our builds. So there's not a lot of moving parts here, but we are leveraging as many AWS services as we can to glue things together. So we're using an EventBridge to call a Lambda. We're using the Lambda to then put something into CloudWatch. Scaling rules, so all these things are kind of happening and we're not having to deal with all that logic ourselves. So this is kind of V1 implementation that we went with. Then we looked at, I don't know why it takes so long to load. There's like a weird transition going on here. We'll see what happens when we go back. So we then implemented a thing called function URLs in Lambda, which was kind of a more advanced way of executing our pipelines, and I'll talk about that, what that means for people who are not familiar with Lambda function URLs, because they are relatively new. I think they came out in the middle of last year. And it was just a different way of us starting to execute our pipelines and to make that process a little bit faster rather than having to wait for the EventBridge to kick off. So for the services and techniques, as I mentioned, our first layer of integration integration was with EventBridge. So essentially it was just a really dumb cron scheduler. It ran every couple of minutes, triggered a Lambda function to test if there was any jobs in our CI/CD pipeline that needed to be run. It's pretty easy, pretty simple to use. 14 million invocations for free. It's a lot in any kind of account, so it's a very low cost kind of implementation. You're having to run any serves, do any sort of cron job. It's fairly simple, as you can see through some of these screenshots here. Not very hard to do, set a rate, whatever it might be. Has a few drawbacks in terms of how fast this can execute, which is why we looked at something called function URLs. So for those that are not aware, function URLs came out in April last year, and it was a way of accessing your Lambda function without having to go through an API gateway. So traditionally, if you wanted to hit a Lambda function through a HTTP endpoint or HTTPS, you would have to create an API gateway. And this is really painful. I had this for another client. We had to deploy a whole API gateway for a single Lambda function just to hit one endpoint. And yeah, okay, that wasn't costing us a lot of money, but it adds complexity into the implementation. It just adds another layer of my network traffic has to go through and I've got to configure this thing that I don't necessarily have to worry about. So using Lambda function URLs allows you to have that one URL. It's unique for that specific Lambda. You can point it at a version or the latest, and allows you access straight into that function to then execute the code. And that's really great for us because in our implementation of GitLab, we've got a thing called webhooks. And we can use those webhooks to say anytime that someone commits a piece of code, go and tell this webhook, this URL, to go and execute some sort of code. So when someone commits their code, those webhooks run, the Lambda function runs there, almost instantaneously. So you're getting, this process is kicking off straight away. And we're talking about virtually no cost here. So these function URLs, you can add them onto your Lambda function, and all you're paying for is the Lambda runtime. So you're not having to pay additional money for this. So again, another reason why utilizing newer functions in AWS and keeping up to date with our knowledge of services in AWS can be really useful. But there's a little asterisk I've put down the bottom around security. So previously, you'd have something like an API gateway, and you'd have maybe a WAF or some sort of security rules API whitelisting, whatever it might be on the front of your API gateway. Unfortunately, Lambda function URLs are very basic and they don't provide any of that functionality. And they only provide functionality and security in two kind of ways. One of them being through AWS IAM. So someone who's authenticated, has access keys or an IAM role, is able to access the URL and then actually execute that function. Or the other one being no security at all, which is a bit crap because essentially you've got this function that sits on the internet and allows anyone unauthenticated access to your function URL. And since our GitLab was hosted in one of those other clouds, and the webhook doesn't actually have any security connected to it through the GitLab UI and how it works and functions, we had really no way of actually adding security into this. So the only mitigating function and technique we have at the moment is Lambda concurrency. So we limit the amount of concurrency and we limit the data that the function returns back. So essentially it just returns back a 200 at all times. That way, if anyone was to hit this from the internet, we're not exposing any data or anything like that. There are some more fancy techniques. I use the word fancy in quotes here to protect these URLs. Things like building your own whitelisting inside of the function, doing some kind of certificate checking or whatever it might be inside of the code is a possibility. Not possible here for the implementation we're working with, but it does give you a little bit of a level of security, but not a very good one because you're still having to worry about that function being executed by people out on the internet. We've had this probably running for 6 months or so now in 5 or 6 different environments. I'm yet to have any randoms just like randomly smashing my Lambda function, turn the concurrency down to 1, but there is always the chance that people from the internet might just start accessing this URL. So something to be very mindful of if you are going to go down that path. So like any good CI/CD pipeline where we're trying to save as much cost as possible, we want to make sure our environment is as small as possible. So you don't want to have things running in EC2, our EC2 runners or whatever it is running in the environment when there's nothing happening. Some of our internal projects go months, maybe years without having any code changes. We don't want this thing just sitting around, churning through money. It might not be a lot, but we don't want to sit it there. So when people commit their code and the Lambda functions run, we want to scale out our environment so that we've got these CI runners to actually execute the code. And we do that with custom metrics and alarms. So our Lambda function is pretty simple. Just checks the pipeline, checks to see if there's any jobs after it's been triggered by whatever mechanism, and posts a metric to say, yes, there is some job or some number of jobs that need to be run, and then just a simple alarm that says if this metric has a value above 0, which means there are jobs to be run, trigger an autoscale group. And again, we're not having to worry here about writing logic into some sort of code, into a Lambda function. We're not having to build this logic ourselves. We're just letting AWS services deal with things like autoscaling. I don't have to worry about typing in my own, scaling up this thing. Am I getting API rate limited? Am I having to deal with connectivity? Let AWS's services as a whole kind of build out this kind of flow of traffic from, yes, I need to increase my autoscaling group. Well, I've got the need for it to actually happen. That CloudWatch happens, the alarm gets triggered, we create an autoscale group, we tell the autoscale group to increase itself. That then goes and increments the number of EC2s in our environment. Fairly easy to do. Something that people usually do with things like autoscale groups, and they might just look at things like basic metrics. We're kind of taking this a little bit step further with publishing our own metric here. That's great, we've got things scaled out, we've built some pipelines, we might have built some code. Now we come to the point where we actually need to scale in our environment. And scaling in is always a little bit more tricky than anyone's actually done autoscaling. Always trickier than trying to scale out. It's easy to scale out because you know there's demand. How do you know that you need to scale in? Because there's often a few multiple pieces of input that you need to consider. And especially in our situation, you don't want to get to a point in any autoscale group where you're scaling in and out too constantly. You're dealing with churn because your runners or whatever it might be, scaling up to meet demand, you don't think you've got the demand, so you scale down, and you're building it up again. No, that takes time, 2 or 3 minutes every time you have to launch an instance. How do I remove that so I don't have to worry about it each time? And how do I deal with things like idle? How do I deal with this thing that's going to run? It's maybe run for 5 minutes, but I have a job that needs to run in another 5 minutes. How do I deal with that so again, I don't have to worry about that churn? The logic we had was just based on the number of jobs in a queue. So essentially we said if there's no jobs in the queue, the function just puts a custom metric on, and I'll show that later, that says there are no jobs to be run, scale down the environment. But as I mentioned, we don't necessarily want to scale down immediately. We want to wait a period of time, essentially build in some sort of idle process. And during some of my research through AWS, there's all this thing called avoiding premature transition to alarm state. Kind of a long, lengthy thing there. But it's the way that CloudWatch works to essentially say, I don't want to trigger alarms too early. I want to have a situation where alarms don't get triggered by accident, which then triggers an action too early on in whatever process that might be. Just something to note here, when you are using scaled in and you are using CloudWatch, if you say, and I'll go through the example, this is supposed to be here for 10 invocations or 10 minutes, there's a bit fuzzy logic there. Sometimes it's more or less. Sometimes a bit more than that. So I'll show that through the example. So if we think about this avoiding premature transitions to alarm state and how that works in kind of practice. So with CloudWatch, if you're familiar, you set a period, which is the number of how long it looks at a metric for, how many data points to alarm. So if you've got 10 data points, which would here be 10 minutes, out of those, 2 of those need to be in an alarm state. And I've got a little bit of thing here about which X's and O's and what each one of those means. So if I've started off with kind of a period of time, and I've got this metric, which the first minute there is no data, then I've got a breach, which is the X. So that means something of my metric has gone up or below, above or below whatever threshold I've set. My third minute, I say that's still within, now it's gone below or above, so it's not breaching anymore. But then I've got another situation where it again goes and my alarm can be triggered here. I've got a breach of what I've set in my alarm. Essentially now here, all we've had to do is wait for 4 minutes because we've had 2 of our alarms be triggered within that 10-minute period. And in that situation, CloudWatch does its thing. It says, my alarm's been triggered. Don't wait the whole 10 minutes, just trigger my alert now and then perform whatever action I need to. And that's normally what people will do. They say, if 2 out of 10 minutes this happens, tell me, send me a notification, auto scale up or down, whatever it might be. But as I mentioned with our Lambda function, we've got this kind of Lambda function that runs when the pipeline finishes and it says, hey, we've got no pipelines to build. But we kind of want to decentralize that. We want to take away and build in this idle time using kind of the capabilities of CloudWatch. I need to keep those running for a little bit longer. But I have no way of re-triggering this function, this metric, in 30 minutes or 20 minutes time to say, hey, I want this to now scale down. I've got to build that logic into CloudWatch using the premature state. So if I look at what that actually means in practice, again, I've set my period to 1 minute. But this time I have 10 data points out of 10. So before I said, if 2 of my data points out of 10 will trigger an alarm, this time wait for all 10 data points in that. So 10 minutes worth of data points to trigger before you actually do anything. And again, this time we treat anything you don't send. So if you don't send any data, we treat that as missing. And we go through the normal gamut again. So we had some data, we had a breach in the CloudWatch, we didn't have it this time. Again, now we've got to the same situation where the alarm, where we've breached the metric for the second time. So the fourth time the second time in 4 minutes. Previously, this would have alarmed, but because we're waiting for all 10 data points here, we don't have any breach, we don't have any alarm being triggered at this point in time. We fast forward, we keep triggering, we keep checking every minute. CloudWatch keeps checking every minute, and we get to the 10th minute or the 10th period. Here, 10 periods being 1 minute, and we set an alarm. And we send this alarm now. So now we've got to a situation where, even though it's been 10 or so minutes, however many periods it needs to be in the future, our alarm has been triggered because CloudWatch has said, right, now we've got enough information because now we've collected enough data points to say, yes, this is in fact a situation where we want our alarms to be triggered and then to perform some sort of action. And this was really good in terms of our idle state because it means that we waited the whole 10 minutes or whatever is in this example for the function to then perform a scale in action because we've waited that whole time rather than doing it early on. And even though these were blank, we didn't have any data there at that time, it didn't matter for the alarm because those were just treated as missing, and CloudWatch has ways of ignoring those. If we look at another example here, and the same kind of thing, 10 data points, gone for 10 minutes, we fast forward again. We do have situations where our Lambda function will run and we've built our little job and it's going to put the metric on there, we've built the pipeline and it said, nope, now we've got nothing to run, please scale me in and wait that 10 minutes period of time. But then on the 6th minute, the functions come back and said, oh no, wait, there is actually now something to run again. So the Lambda function puts the metric on there, and now CloudWatch sees that as not a breaching metric, but something that's now pushed it over the other threshold. So now when we fast forward to the 10th minute, we don't send our alarm. Because essentially by having this little O here, which means that our metric has gone above our accepted, which means that we don't want to essentially scale in, it tells the CloudWatch just to kind of ignore everything that's happened previously and start our new 10 minutes from where that first alarm, that first breaching data point was. So essentially we've got a situation now where we're going to wait, our 10 minutes doesn't finish here, our idle time for our runner. We're now back to kind of square one and we go through that whole process again of waiting the number of minutes and using CloudWatch to do that. It does sound very complicated, and hopefully my example when I walk through a little bit in a minute will be easy to look at, but it gave us a really easy way of using, again, AWS services to kind of do some of this complex logic for us that we didn't have to build in ourselves. I didn't have to write some Lambda functions to do some things for us. We're letting CloudWatch kind of do its thing and kind of deal with some of the logic for me. Again, I'm not having to write code, I'm not having to maintain anything, I'm not having to build any services, I'm just having to do a little bit of configuration on my side. As part of any good CI/CD, so we've got our CI/CD pipeline, we also use things called lifecycle hooks if you haven't used those in autoscale groups. So we might have 50 jobs that need to run, so we've got 50 runners kind of building out and around, and because we've got this decentralized kind of environment, when we try to scale in our environment, AWS doesn't know where jobs or things are running. So we use these lifecycle hooks to say to AWS, hey, if you scale in my instance, don't terminate something that's actually trying to execute some sort of job. So AWS goes through this process of saying, hey, this instance I need to just scale in, little batch job that runs on the machine that says, hey, AWS, I'm actually performing a task at the moment. Please wait a period of time. Don't scale my instance in until I give you the all clear. And this is really good because you might have a job that's running for 5 or 10 minutes, whatever it might be. You don't want that thing to be scaled in at that time. You need it to wait. And AWS can wait a really long time for some of these services to be scaled in, which is really good because you can let your job run. You don't have to worry about been deleted. Then when it's done, AWS go, thank you for finishing that. I'll scale that instance in, again, removing a lot of the logic and difficulties around having to do scheduling for us. AWS is doing that for us. And luckily for us, you can also do things, so lifecycle hooks also have the ability to have a heartbeat, and that essentially says, hey, after a period of time, if this thing doesn't actually say it's finished, just go and terminate it anyway. So we've got that kind of backup process that, yeah, this thing said it was processing some sort of job, but it didn't actually tell me if it was doing it, just go and kill it anyway. So again, we're not having to build any kind of custom logic in to a Lambda function, to any sort of auto scaling. AWS has got this functionality a little bit built in for us. And then they do have a thing called scaling protection as well. For anyone who's used auto scaling groups, it gives you the ability to say, hey, this instance is really precious for whatever reason. Don't just, in no situation, go and delete this thing. So that can also be a good backup for people who are using autoscale groups, but they've got this one little instance here that's a bit of a pet for some reason. Don't go and delete my instance there. Keep that running for a little bit longer. So we think about kind of all these things that are running. We've got CloudWatch, we've got Lambda functions, we've got some EC2s. The beauty about a solution like this, and it gets a bit complicated in terms of all the AWS services, is essentially for free. When things aren't running, our Lambda function, our function URLs, CloudWatch, I think CloudWatch costs like 50 cents per metric per month. We're talking about a cost here that's in the cents. Not something where if I'm running some sort of EC2 or some really complex logic, it's costing me $10, $15, $20, $30, $50, $100 kind of a month. And then as part of this solution, we use spot instances to launch instances. So you're talking about 5 cents an hour to launch something. So it's a relatively kind of cheap way of doing things. And that's kind of the beauty of using a lot of these AWS services and stitching them together, is that you're essentially paying very minimal cost to do all these things. Letting them deal with some of the complex logic, not having to deal with and maintain code, because the cost of engineering is also never factored into some of the overall cost of a lot of these things. There are other solutions that kind of do similar things. One of them, if you're familiar with GitLab, is called Docker Machine, where you just kind of sit an EC2 instance out into the environment. It just kind of polls GitLab to see if there's anything to run. That's great for people who've got kind of a large environment and they've got this thing sitting there, but again, we wanted a solution that didn't worry about patching, didn't have to worry about maintenance. Having an EC2 sitting in an account for 6 months, you never know if it's actually working. Someone has to SSH in there to rotate something, to perform some sort of updates. We don't have to worry about that kind of thing because we're only spawning up these instances when we need them, and we've got Lambda functions and all that kind of self-service, and we don't have to worry about patching them. There's always little trade-offs there, but essentially that's why we went down this solution. Minimal patching, no patching, minimal maintenance or verification as it goes. So I'll attempt to go through a little bit of demo, so we'll see how this goes. So in my environment here, I did just run this a little bit before. So I have no instances running, so I don't have any GitLab runners or anything running at the moment, and I want to make a code change. This is my website. It's a little email generator that we use internally, and I want to push change to that thing. So I've got my change in a branch, and essentially I just want to I'll just change the heading. So user group, just fairly simple change. For sake, we'll just commit that change. That job's been pushed. We have a look over here at our CloudWatch. Did run this recently, so hopefully a different Lambda spawned. We see here that because of the function URL, so if I look at my webhook, I've created a webhook in my environment. This is my URL for my Lambda function. Pretty simple kind of HTTPS endpoint there that matches that. GitLab has gone out and said, hey, because there's been a commit to in my environment, I've pushed, there's a job event because I've got a workflow. Go and run that Lambda function, which we can see here as part of this log, event log. So you can see the Lambda function's run. It's detected that there is some jobs that are pending and need to be run. We come over to our alarms, and because that Lambda function's put that metric there, we see that the pending job alarm has been triggered because we've got a job that needs to be run. So because the metrics and the alarms are set up, the alarm essentially says, hey, when this gets triggered, go and increment the autoscale group that I've got attached to this alarm. So I go over here, I can look at my autoscale group. I've seen that CloudWatch has now gone and incremented my autoscale group for me. I now have one instance. come back to my instances, and I can see that's been spawned for me. So now I've gone from essentially an environment that was dormant, not doing anything. I've pushed some code that's gone through the whole mechanism of a webhook that's triggered a Lambda function. The Lambda function's put in the metric. The metric's been detected by CloudWatch. The alarm has then picked it up and said, that's a breach. That's something we need to detect. Increment my autoscale group. Autoscale group's been incremented, and that EC2 instance will then boot itself up and connect itself to the GitLab server. Does take a few minutes to do that. Hopefully not too long. I swear it was a little bit faster before. And then it'll essentially register itself and execute we can see here, it'll execute this pipeline once that runner is available. But if we go back to kind of what I was trying to explain before about this alarm state, we can see here, I ran this earlier, and at 7:39 during the last presentation, I ran this job, and essentially it finished and said there was no jobs to run. And we can see here there's a period of time when my alarm has said, well, that's great, I've got this metric, I've put it there, but don't perform an action yet because I haven't gone through my data points yet. I haven't got all 30 of my data points. It was 10, I made it a little bit faster before. After the period of time, it collected all those data points, then it triggered the autoscale group to then to scale in my environment. So rather than having to wait, triggering that straight away, I was able to control how long that instance was available for our environment. And during that time, if I had have gone and created another job and pushed some more code, it would have gone and re-executed and would have been able to reuse that same GitLab runner. Annoyingly, this thing has not bootstrapped itself because these things never go as fast as you want them to, but hopefully in the next 30 seconds or so that will be done. There we go. So now we've got our runner, it's registered itself here. It's doing its little bits and pieces, downloading some code, and essentially it will go and propagate that change out to our environment. Hopefully soon. Why are these things always so slow when you run them in front of people? I like to get it finished because it's like I feel like it's just smoke and mirrors before that point. Anyway, not important, but hopefully, there we go. So a GitLab runner runs. The way the pipeline runs, we've essentially got this little URL, and now we've gone and pushed our code up here. Our runner's done its job. It'll now wait for, again, a period of time before, if any jobs run, it'll either reuse the runner, or if the 30 minutes, which has been set up here, passes without any jobs needing to execute, the autoscale group will then autoscale that bit down, and we'll have an environment with zero cost again. And I didn't realize there was a requirement to have like a quote at the end of your slides from the last presenter, so apologies for that. But yeah, hopefully that was somewhat insightful for people who are maybe new to some of these new AWS services and thinking about how they might stitch some of these things together. That's it.
Does anybody have any questions? No questions from there. I'll ask a question. So it's very nice setup you've got there. It looks like it's pretty cost efficient. Did you look into using Code Pipeline or anything like that? A tool that's designed to do something in this vein?
Yeah, so because we've got GitLab, we wanted to kind of keep, one of the things, we have other clouds. We often have people who are using some of the other clouds, so we didn't necessarily want to use the pipeline. We wanted something that was semi-reusable across some of the other things. So we're talking about doing something similar for GCP and Azure, so we didn't necessarily want to lock ourselves into using just AWS specific tooling like Code Pipeline or Code Build. And again, because our code's in GitLab specifically, it's a little bit harder to get that uploaded and into Code Pipeline or Code Build. So that's, again, another reason why we went down that path.
Cool. Any other questions?
I will make the present. I'll go and send out the slides if anyone's interested with all the links and everything there after this presentation. So if you're keen to have a look, go and have a look at that on the GitHub. Message me on LinkedIn or whatever it might be if you've got any questions.
So that brings us to the end part of the program. As mentioned, we've got a marketplace where everybody who's hiring, if you can hold up your hand, Rob will bring a microphone and you can. Yep.
You hire it.
Yeah. Talk to Anthony.
Cheers. Hey, yeah, my name is Santiago and I'm working at Atlassian as an engineering manager. I've been there for pretty much 5 years. And yeah, we're looking for principal developers, senior principal developers, some other engineering managers, design, machine learning, scientists and whatnot. So yeah, there's a lot of postings in Atlassian.com/careers, or just come talk to me and yeah, we are on LinkedIn and whatever. We'll sort out things. Not promising a job though.
Was there anyone else? Pop your hands up if you hiring.
Cool. Looks like there's a bit of a hiring freeze going on.
Lucky for those who are hiring then. They
Yep.
got the pick of the litter.
Before we finish this up, I was asked by Matt at the back there to point out he's one of the organizers of Serverless Days, so if you have any questions, go bother him. Yep. And then with that, I want to once again thank our sponsors, our gold sponsors, CMD Solution, Versant and Civo, as well as NAB, who I really need to add to this slide. Thank you for clapping. As you can see, Chris left, so I did not pay him enough to stay. We'll be back next month on the 29th of March because it's a month with a decent number of days in it. We'll be back at our regular location at the NAB Hub on 395 Burke Street. So I hope to see you all there and thank you all for coming. I hope you had a great day. Thank you.